Now let's look at the bones, starting with the humerus. We've looked at its proximal end already. Now let's see the distal end. It's flattened from front to back, with a complicated articular surface and two prominent lumps, the medial epicondyle and the lateral epicondyle. These are major muscle origins, as we'll see. Above each epicondyle is a ridge, the epicondylar ridge. Here's the lateral one. The articular surface is in two parts. The pulley-like trochlea articulates with the ulna. The rounded capitulum articulates with the radius. Now we'll add the radius and the ulna to the picture. The big hollow on the back of the humerus, the olecranon fossa, accommodates the end of the ulna, the olecranon, in full extension. Now let's look at the two forearm bones, the radius and the ulna. They're different in that the ulna is bigger proximally, the radius is bigger distally. They're also different in that the radius rotates, the ulna doesn't. The two bones are held together by two radioulnar joints, the proximal and the distal. Forearm rotation happens simultaneously at both these joints. The two bones are also held together along most of their length by the strong but flexible interosseous membrane, which prevents the two bones moving lengthwise relative to each other. Let's look at the proximal ends of the radius and the ulna. We'll look at the ulna first. The main feature of the proximal end of the ulna is this large curved articular surface. The curve that it forms is called the trochlear notch. It articulates with the trochlea of the humerus. The very proximal end of the ulna is the olecranon. The triceps tendon is attached to it. This projection is the coronoid process. Distal to it, this rough area, the ulnar tuberosity, marks the insertion of the brachialis tendon. This small curved surface, the radial notch, is where the head of the radius articulates. This is the head of the radius. This is the neck. The end of the head articulates with the capitulum of the humerus. Its curved side articulates partly with the radial notch of the ulna and partly with the ligament that surrounds it, as we'll see. Just distal to the neck is the radial tuberosity, which is the insertion for the biceps tendon. The elbow joint is stable. That means it stays together for two reasons, partly because of the strength of the ligaments, which we've seen, and partly because of the shape of the bones. The humerus and the ulna interlock closely and deeply. Their surfaces are curved in two planes, from front to back and from side to side. The elbow and the proximal radioulnar joint are considered to be all one joint because they're enclosed in one continuous space. By contrast, the two joints that we'll look at next, the distal radioulnar joint and the wrist joint, are physically separate, even though they're close together. So we'll look at them separately. To understand the distal radioulnar joint, let's look at the distal ends of the radius and the ulna. The head of the ulna has a rounded articular surface. This part articulates with the radius. This part articulates with a key structure that we'll see shortly, the triangular fibrocartilage. The pointed tip of the ulna is called the ulnar styloid. The broad distal end of the radius has two articular surfaces. This large one articulates with the proximal row of carpal bones. This small surface articulates with the ulna. This point is the radial styloid. Now let's look at the wrist joint. Though we often speak of it as one joint, there are really two joints here, very close together. They're called the radiocarpal joint and the midcarpal joint. To understand them, let's look at the bones. We'll look at them this way up. 8 small carpal bones form the carpus. Distal to the carpus are the metacarpal bones, numbered 1, 2, 3, 4, and 5. The carpal bones are in 2 rows, a proximal and a distal. The bones in each row are attached closely to one another. The 4 bones of the proximal row are the scaphoid, the lunate, the triquetral, and the pisiform, which sits by itself on the triquetral. The scaphoid, the lunate, and part of the triquetral articulate with the distal end of the radius to form the radiocarpal joint. The distal surface of the proximal row articulate with the distal end of the radius to form the radiocarpal joint. The distal surface of the proximal row forms a deeply concave notch which the bones of the distal row fit into. The bones of the distal row are the trapezium, the trapezoid, the capitate, and the hamate. The capitate and part of the hamate project proximally. The bases of the 5 metacarpals articulate with the distal row of carpal bones. The first, the one for the thumb, articulates by itself with the trapezium. The other 4 articulates in a row here. The distal row of carpal bones articulates with the proximal row here to form the midcarpal joint. The projecting capitate and hamate fit into the notch in the proximal row. When flexion and extension occur at the wrist, the movement happens partly at the radiocarpal joint and partly at the midcarpal joint. When radial deviation and ulnar deviation occur, the action happens mainly at the radiocarpal joint. Like the elbow, which is held together partly by the interlocking shape of the bones, the wrist joint is held together entirely by the strength of its ligaments. The 2 collateral ligaments hold the bones together in radial abduction and ulnar abduction, and the radiocarpal ligaments hold them together in flexion and extension. The strength of the radiocarpal ligaments also ensures that when the radius rotates, the hand goes with it. Before we move on to look at the muscles, let's review what we've seen of the bones and joints. On the humerus, here's the medial epicondyle and epicondylar ridge, and the lateral epicondyle and epicondylar ridge. Here's the capitulum and the trochlea. On the proximal ulna, here's the trochlear notch, the olecranon, the coronoid process, the ulnar tuberosity, and the radial notch. On the proximal radius, here's the head, the neck, and the radial tuberosity. On the distal ulna, here's the head and the ulnar styloid. On the distal radius, here's the surface for the ulna, the surface for the wrist joint, and the radial styloid. Here's the scaphoid, the lunate, the triquetral, and pisiform, the trapezium, the trapezoid, the capitate, and the hamate. And here are the metacarpals.